Okay, welcome back for another deep dive. We've got this really interesting Q&A between an experienced A320 captain and a first officer.
Yeah, they were really getting into the weeds on the Autobrake system.
Exactly. So our mission today is basically to unpack that conversation, figure out what this system does, why they use it, what those different modes actually mean.
All based on what they discussed, yeah.
Yeah,
It's
yeah.
not just a simple button press, is it?
No, not at all. The way they described it, it's like this extra precise helping hand on the brakes.
But with layers. Lots of layers in specific conditions.
Right. So let's start there. Based on their chat, what exactly is the auto brake?
Oh.
And maybe more importantly, why use it over just, manual braking?
Okay, so the captain laid it out pretty clearly. It's an automated system designed to give a specific preset deceleration rate, either after landing or during a rejected takeoff.
A predetermined rate.
Yeah, and the why is crucial. He really hit on consistency and safety. It brakes much more smoothly and predictably than a person might, especially, say, on a wet runway or if there's a crosswind.
Consistency. That makes a lot of sense when things aren't perfect outside.
Totally. And they also talked about efficiency. Using auto brake means the pilots aren't focused solely on modulating the brakes right after touchdown.
Right, they can focus on steering, managing the reverse thrust.
Exactly. Other critical tasks. Plus, that smoother application, it's generally easier on the brakes and landing gear components over time.
Okay, so smoother, consistent, automated stopping. Good reasons. Now, they really dove into the modes, low W, MED, and max. What's the difference there, according to them?
So the captain explained it's all about the rate of slowing down, how quickly the plane decelerates. Low W is the gentlest setting. It gives about 1.7 meters per second squared deceleration. They'd use this for your standard everyday landing on a nice long dry runway.
Okay, so normal ops, plenty of space, good weather, comfortable rollout.
Precisely. Then you've got MED. That bumps it up to around 3 meters per second squared.
So a bit more bite.
Yeah, a noticeable increase. This is for when you need a bit more stopping power. Think shorter runways, maybe it's wet, or perhaps you need to make an earlier runway exit. It's sort of the go-to when conditions aren't quite ideal.
Makes sense. And max. That one sounds, well, maximum.
It is. And the captain was very specific here. Max gives the highest rate, about 4 meters per second squared for a landing scenario. But its main job, its primary design purpose, is for a rejected takeoff and RTO.
An RTO, okay.
Yeah. He stressed that while you could technically use Max for an emergency landing on a super short, contaminated runway where stopping is absolutely critical.
You wouldn't normally choose it for landing, even on a shorter field.
Exactly right. That was a key point in their discussion. Max braking is very aggressive. It's uncomfortable for everyone on board and puts a lot of stress and wear on the brakes. It's really reserved for those stop and W situations, especially the RTO.
Got it. Not routine. Okay, the FO also asked about engagement. Right. How does it know when to kick in? And importantly, how does the pilot take back control?
Yep, good questions. They covered that. It's armed beforehand during the takeoff checks for RTO protection or during the landing checks.
Okay, armed and ready.
Then for landing, the captain explained it needs 3 things to happen at the same time. Both main landing gear have to be down, the ground spoilers need to pop up, and both thrust levers must be pulled back to idle.
All 3 conditions, if one's missing.
It won't engage. Simple as that. Needs all 3.
And for the RTO max setting?
That engages if you're above 70 knots on the takeoff roll and you pull both thrust levers back to idle. Abort decision.
Okay, and overriding it. Taking control back.
This is crucial, and they emphasized it. The pilot always has the final say. Just touching the brake pedals, applying any manual brake pressure, immediately overrides and disarms the auto brake system. Instantly. You can also switch the selector knob off, or during the landing roll, if you advance the thrust levers again, that'll disarm it too. The big takeaway was pilot authority. Automation assists, but the human is in command.
That's definitely reassuring to know. Did their conversation touch on times when you might not want to use it or be extra cautious?
Yeah, the captain mentioned a couple of scenarios, like landing with a significant tailwind. That can make the rollout distance a bit unpredictable, so manual braking might give more direct control.
Okay.
Also, if you have a long float before touchdown, using up runway, you might disarm it right after landing just to ensure you have immediate maximum manual braking available if needed for the remaining distance. And obviously, any system malfunction means following procedures, likely involving manual control.
Right. Procedures first. What about brake temperature? Does the auto brake keep an eye on that?
Good question. They clarified it doesn't directly monitor temps. That's still the pilot's job, checking the ECAM display after landing.
Mhm.
But because it applies brakes so consistently, it can help manage temperatures better than, say, potentially pumping the brakes manually. And they did touch on using reverse thrust effectively with the Autobrake. That combination really helps slow the plane down efficiently and saves brake wear.
So, bringing it all together, what's the main takeaway from their discussion on this system?
I think the core message from their Q&A was that the Autobrake is a really powerful tool. It definitely enhances safety and efficiency.
But it's not magic. It's one part of a bigger picture. Pilot judgment, monitoring what the automation is doing, understanding its limits, that's all still paramount.
Absolutely. The automation is there to assist, just like they said, but the pilot is the ultimate authority, always ready to step in.
Yeah, and understanding these systems, especially hearing pilots discuss the practicalities, it really highlights all the layers of design and the real-time decisions involved in flying safely. It's quite a dance, isn't it?
Correct.
Between the automated precision and the human oversight.
It really is.
Yeah.
And that actually raises a pretty interesting thought, kind of building on what the captain implied. And
Yeah.
think about that dynamic. Automated systems working under human supervision with clear rules for engagement and override. Where else do you see that same kind of interaction playing out? Not just in aviation, but, in other complex systems we use every day.
That's a great point to ponder. Where else does that balance exist? Okay, thank you for joining us for this deep dive into the A320 Autobrake, straight from that pilot Q&A.